Hi, today we're doing Unit 7, Lessons 1 and 2, finding unknown inputs, and then when and why do we write quadratic equations. So from the lesson for today, you will be able to explain the meaning of a solution to an equation in terms of a situation. You can recognize the factored form of a quadratic expression and know when it can be useful for solving problems. And you can use a graph to find the solutions to a quadratic equation, but also know its limitations. We're starting out on page 162 in your workbook. It says, what goes up must come down. So the warm-up says, a mechanical device is used to launch a potato vertically into the air. The potato is launched from a platform 20 feet above the ground with an initial vertical velocity of 92 feet per second. So the function is negative 16t squared plus 92t plus 20. And that models the height of the potato over the ground in feet. So you see the feet are on the y-axis and the seconds are on the x-axis. So here's the graph that represents this function. For each equation, be prepared to explain your reasoning. So what is the height of the potato 1 second after launch? One second, I go up to the graph and I see it's about 100. But to find the exact answer, we're going to plug in 1 into the equation to find the exact value. It is 96 feet. Here's how I solved the problem. I plugged in 1 wherever I see t. So negative 16 times 1 squared plus 92 times 1 plus 20. So I know we have 1 squared is 1. 1 times negative 16 is negative 16. 92 times 1 is 92 plus 20. So if I can take 16 away from 20, I know I'll have 4 left over. So 92 plus 4 will give me 96 feet. Number 2, it says 8 seconds after the launch, will the potatoes still be in the air? Do you think that's true or false? No, that is false. And how do we know that? If you look at the graph, you can see at 6 seconds or just before 6 seconds, the potato is on the ground. So it won't be in the air after 8 seconds. Will the potato reach 120 feet? If we take a look at the graph, 120, I see the potato reaches 120 in 2 different times. So yes, it will reach 120 feet. What are the 2 times when that will happen? It happens in 1.5 seconds. And it happens again at 4.3 seconds. When will the potato hit the ground? Well, I'm looking for when the height is 0. When does it hit the ground? It happens just before 6 seconds. So I'm going to say about 6 seconds. All right, the next activity is on page 163. So here is a diagram that shows the picture with a frame that is the same thickness all the way around. The picture is 7 inches by 4 inches. The frame is created from 10 square inches of framing material. So in the form of a rectangle measuring 4 inches by 2.5 inches. So they're saying they have framing material that is 2.5 inches by 4 inches, and they cut it up into strips. So this total area is 10 inches squared. They cut it up to create the frame around the picture. So it says write an equation to represent the relationship between the measurements of the picture and of the frame and the area of the framed picture. Be prepared to explain what each part of your equation represents. So I'm going to start by labeling with information that I have. I know the picture is 7 by 4 inches. So I know this is 7 and this is 4. This is 7 by 4 picture. Okay. What I don't know is how much they cut for the frame. I don't know how wide the frame is. So I'm going to replace that length with an X. Okay. So I know that this length is X and this length is X because they're using the same length and width for their frame. So I have 4 of these X squares. Each corner would represent an X squared. Here's an X by X. Here's an X by X. And here's an X by X. So I have 4 X squares. I also have other rectangles in here. So if I look at this rectangle on the right-hand side, it is X by 4. 4 times X would be 4X. I have 2 of them because I have another one over here on the left-hand side. So there are 2 4X's. On the top and the bottom, I have 2 7X's. So if I do 7 across and X up, 7 times X will give us 7X. So on the bottom, same thing. 7 times X is 7X. So if we add 7X plus 7X, that will get us the total frame around the outside. We know that total area for the frame has to be 10 square inches. So we could simplify this equation and we could write 4x squared plus 4 plus 4 is 8, 7 plus 7 is 14. Add it all together, we would have 22x, and it has to equal 10. All right, that's one way to represent it. There's another way to represent it. You could take the full area, including the frame and the picture. So I could take the full length on the top of the length would be x plus 7 plus x. So I have 2x plus 7. I could take the full width or the height, which is 2x plus 4. 2x plus 4. But if I only want the area of the frame, I have to take away the area of the picture. So the picture was 7 by 4. So if I take away that picture area, then I would get what's left over on the outside would be the 10 square inches for the framing. So this would also represent the same equation we have up here. If I were to distribute the 2x plus 7 times the 2x plus 4 and simplify this, I would get 4x squared plus 22x. You can go ahead and try it on your paper. So number 2 says, what would a solution to this equation mean in this situation? So if we solve for x, what does that mean? What are we trying to find? So x represents the thickness of the frame when all the material is used. Write that down. It represents the thickness of the frame when all of the material is used. We haven't learned how to solve quadratic equations yet, that's what this whole unit is about. We're going to learn how to solve quadratic equations. So if I'm looking for what value of x would make this statement true, 4x squared plus 22x equals 10, the value is 0.422 inches. Now you're going to ask me, how did I get that answer? You will learn how to get that answer in this whole unit. We are not going to show you how to get the answer for this particular problem. I'm just telling you the answer is 0.422 inches. Okay, so I will show you how to find it. If you put in 4x squared plus 22x in Desmos, is my equation up here, and you put y equals 10, that would be a horizontal line at 10. Where they intersect, where they're equal to each other, would be your solution. So here, if I have my quadratic equation and my linear equation, they're matching here at 0.422, 10. So this would be our value for x that I just shared with you earlier. So the graphing is one way to find the solution. We'll show you other ways to find the solution throughout the unit. All right, go ahead and turn to page 170. Page 170. How many tickets? So this is using a linear equation. The expression is 12t plus 250. It represents the cost to purchase tickets for a play. T is the number of tickets. So there's this extra fee you have to pay. Usually when you buy tickets, you have to pay a fee for them to print the tickets. So be prepared to explain your response to each question. A family paid $62.50 for tickets. How many tickets were bought? Well, if we know the total that they paid and we know the expression for the cost for purchasing tickets, we can set them equal to each other and solve for t. So here's my equation. To solve the equation, we have to subtract 250 on both sides. So if you take away 250 from 62.50, you're left with $60. So if I do 12t divided by, or 12, 60 divided by 12, that will tell us how many tickets that they purchased. So the number of tickets this family purchased was 5. All right, a teacher paid $278.50. And they're using the same expression. So we have to solve this equation to find how many tickets were bought. So same process. Solve to find how many tickets were bought. Okay, did you get 23 tickets? Yes, so if you subtract 250 and then divide by 12, you get the solution is 23. So the teacher bought 23 tickets. All right, here's that flying potato again. The other day, you saw an equation that defines the height of a potato as a function of time after it was launched from a mechanical device. Here is a different function modeling the height of a potato in feet t seconds after it being fired from a different device. So here's the equation. Negative 16t squared plus 80t plus 64. What equation will be solved to find the time at which the potato hits the ground? Well, when it hits the ground, the feet would be at 0 feet. So the equation that we're going to solve would be 0 equals negative 16t squared plus 80t plus 64. This is the equation we're trying to solve. So it says use any method except for graphing to find a solution to this equation. All right, try it out on your workbook and see if you can find what the answer would be for the time. All right, here's what I would do. First, I noticed that 16 goes in all 3 of these terms. So I might simplify by dividing all 3 terms by negative 16. So I would get t squared minus 5t minus 4 equals 0. Okay, so I noticed that I can't really factor this yet, and we don't know how to factor, so we can't use that strategy. So I might be able to move the 4 to the other side. So if I add 4 on both sides, I get 4 equals t squared minus 5t. And I notice there are 2 t's on this side. So I could now factor and say, okay, I know a number, and that number times that number minus 5 has to equal 4. The only way we can figure this out is by using guess and check. Okay, because it says we can't use graphing, so I can't use my Desmos. If I guess and check, I'm going to plug in numbers and see what I get. If I plug in 5, 5 times 5 minus 0 would be 0. So it doesn't give me 4. So 5 doesn't work. If I plug in 6, 6 times 6 minus 5 would be 1. 6 times 1 would be 6. So that doesn't work. So I know my answer has to be somewhere between 5 and 6. So now I'm going to find, let's go halfway between there. Let's try 5.5. Okay. When we plugged in 5, our output was 0. When we plugged in 6, our output was 6. So now let's try 5.5. I know 4 is between 0 and 6. So let's try 5.5. If I plug in 5.5, I have 5.5, and then 5.5 minus 5 would be a half. So 5.5, and then times a half. Well, what is half of 5.5? That would be 2.75. Ooh, we're getting closer. I know 4 is going to be somewhere between 5.5 and 6. All right, let's test out one more number. Let's try 5.7. Okay, so if I plug in 5.7 for t, 5.7, and if I do 5.7 minus 5, that would give me 0.7. Okay, so if I do 0.7 times 5.7, let's see what we get. Wow, that was a really good guess. I got 3.99, which is super close to 4. All right, so my best guess for the time would be about 5.7 seconds later. That'd be my best guess using guess and check. Is that the most efficient method to use? No, but we haven't learned how to solve quadratic equations yet, so that's the method we're going to use for now. All right, let's take a look at revenue from ticket sales, page 171. The expressions p times 200 minus 5p and negative 5p squared plus 200p define the same function. It represents the revenue a school would earn from selling raffle tickets at p dollars each. So the question's asking us, at what price or prices would the school collect $0 in revenue from the raffle? So if I know they're going to collect no money, $0, 0 is going to be equal to p times 200 minus 5p. All right, so we're solving this equation. 0 equals p times 200 minus 5p. So I know that one of these factors has to be equal to 0. So p could equal 0, or I could have 200 minus 5p could equal 0. So if we're solving for p, one answer is already 0. The other answer I have to solve. So I'm going to subtract 200 on both sides, and then divide by negative 5. So I'm going to divide by negative 5. We get p equals 40. So this means if the price of the ticket is worth $0 or $40, the revenue is going to be 0. They're not going to make any money because they're not going to be able to sell any tickets. Or if you sell for free, you don't make any money. So the tickets at $0 or at $40 would not make any revenue for the school. All right, so the school staff noticed that there are two ticket prices that would both result in a revenue of $500. How would we find out what those two prices are? So we could set our equation, P times 200 minus 5P, and set it equal to $500. And then we have to solve in order to find when does our expression equal 500. And they said there are two times when this happens. So if you use Desmos to graph this, you'll see these 2 points are when they would make $500. So it'd be about $2.70 or $37.32. So the two prices are $2.68 and $37.32. Those are the two prices where they would make $500. And you can see that in Desmos. All right, so when and why do we write quadratic equations? There are some limitations for solving this equation. Negative 2x squared minus 2x plus 40 equals 10. Guessing and checking is going to take me a really long time. Graphing, I can use the graphing calculator to graph those two equations and see where they're equal to each other. It might take a little bit of time. I can show you how to do that. So if I have negative 2x squared minus 2x plus 40, and we're trying to figure out when does that equal 10. I'm looking for where do they intersect. Right now I don't see it, so I have to zoom out. So it works at -5 and at 4. I realize you can't see my decimals when I flip over to that screen. So -5 and 4, I can see where they intersect. What would be easier is if I could factor that problem. So if I knew that 8 minus 2x times x plus 5 equals 0, that'd be easier to solve than solving this equation. Negative 2x squared minus 2x plus 40, because we haven't learned how to factor and solve. So if I have the factored form, then I can find the answers by setting each of them equal to 0. So I can already see, okay, x will be -5. And if I solve the first equation, 8 minus 2x equals 0. If I subtract 8 and divide by -2, I get x equals 4. So it was much easier for me to solve it in factored form than it was in standard form. Okay? Now, if I know it's equal to 10, I would just say, okay, if x plus 5 equals 10, that would mean the other number wouldn't work. So I don't know if this would be easier to solve now if it's equal to 10. Equal to 0, much quicker to solve. If it's equal to 10, I might have to multiply it out or use my graphing calculator to solve. So which is easier to solve? Well, the second one doesn't have anything to solve because it's not equal to anything. So the first one would have to be able, I'd be able to solve that one, but I'm trying to find out what numbers when I multiply them would equal 10. So I'd have to use my graphing calculator to solve that. There are a lot of vocabulary words that we've introduced. We've talked about quadratic equations, and in this case, this is in standard form, ax squared plus bx plus c. We've talked about factored form, where you see the numbers you're multiplying. They're written as a product. We have standard form, and then we've talked about the zero of a function. So zeros are when the input that yields an output of 0. So when the y value is 0, we're looking for what's the x value.